first thing first, what's left for this course? You must check the calendar, right? You know how to check the calendar? Everyone knows, right? Well, these are the things. Project 5 due on next Friday, not this Friday, 10th of April. Midterm 2, which is not the final exam. It is due on Tuesday, 4/15. And the time window from 4:13 to 4:15. You cannot take the exam without this time period. You take the exam within this time period. These 3 days time period. 13 whole day, 14 whole day, 15 whole day. Okay, but don't start your exam at the very last moment. It will submit automatically before the deadline. And it is comprehensive. Like you can find some question from the midterm 1, but mostly from like after the midterm 1 the content. Some of them should be midterm 1. It is the same way like the multiple choice question, but it is not the final exam. Still, we have final exam. It is due on the final week on 29th, the very last day of doing anything. And this is the final project. I'll be discussing the final project on week 14. I think we have 15th week here. So most of the instructors have started from week 2. I have started from week 1. That's why they have week 11 right now. But week 14 is very short. But in our case, we are week 12. But our week 14 is full week. Week 15 is like 1 class. So in that particular class, I will be discussing the final project. That can be helpful for you as well. Any question? So these are the major assignments. Project 5, midterm 2, and the final exam. Okay, so these are the learning objectives of this week content recursion. We'll be defining recursion, explain how recursive functions differ from iterative solution, identify the base case, recursive case in the recursive algorithm, analyze the recursive function to determine the recursive pattern and the sequence of function calls, implement the recursive solution to solve computational problems such as mathematical sequences or data processing. We'll evaluate and debug the recursive algorithm by verifying the correctness of base case and the recursive logic. These are the learning outcomes. But I would like to go through briefly for the project 5. I already have discussed the project 5 in the last class. But again, here are the project 5 rubrics. You need to implement the random simulation for 3 astronauts, Lance, Sophie, and Finn. They have different movement style. You need to follow those style for the for the choices. Ensure the output is different each time the simulation you run. It's a random. You need to use appropriate data structure, list or dictionaries. Make sure you use list within list or dictionary within a dictionary. The function I have given to you is the plot function, which can help you to draw the simulation path if you're using dictionary within a dictionary. If you're using list within a list, probably you need to modify that function. You can use some necessary global variables that what I've told. If it is a nested list or nested dictionary, for that particular case, you can only use the global variables. And as always, snake case and variable naming the rules are there. If there is a code repetition thing, use loops function, manage the astronaut movements, and the main function with conditional execution. So mostly we have done those things. I think I told you about the simulation and the plotting things. For the simulation, you need to use, for the randomization, you need to use either dot choice function or dot choices function. By the function name, you can see here from the choice, it can return one single choice. From the choices, it returns multiple choices. You need to know the function syntax and definition from the random library. I'll show those things later, but I can assist you now to read those things first. For the plotting, matplotlib, saving file matplotlib. For grouping the information, nested list or nested dictionary. So what are the inputs? The inputs are just 500 steps for those 3 astronauts. Also, the inputs are the astronauts' behavior. Those are like static, not dynamic. You're not putting from keyboard or from command line or from file. Those are like static. Lance, Finn, and Sophie. They have 3 different behavior. 500 step is also static. You are just simulating 500 step. And what's the output? You need to generate 3 images, 3 movement images from 3 astronauts, and make sure when you run your code, it will create a new simulation graph or image every time. Okay. Do you understand the problem specification and the design? Then it's your turn to implement the project, because the project is due next week to start working from this week. Okay. And I already have discussed the Cartesian coordinate system. So for like left, you can just move x-axis by 1, not y-axis. Y-axis is 0. For going upward, you can keep the x-axis as y-axis as it is. Increment the x-axis. Same thing for the downward. You can keep the y-axis as it is, but x-axis -1. For the leftward, keep x-axis. I'm sorry, y-axis as it is, and decrement the x-axis. So it should be different. Like for the upward, y-axis positive, x-axis 0, like nothing. For the downward, y-axis negative, x-axis don't do anything. Okay, so those are the 4 movements, right? Left, right, up, down. And depending on the behavior, you need to add those numbers as a tuple, x and y tuple, and start from the 0, 0. This is the starting point. If it go upward, that means it is 0, 1. So you're adding 1 up. If it is downward, you can add 1 down so that you can find the next point. Then you need to generate all of those points to draw the plot. And for plotting, you need to install the matplotlib on your main on your computer. Otherwise, it cannot generate an image. And you can find those information, like detailed information, from those Geek4Geek and matplotlib. And I already have shared this PowerPoint slide in the modules page. So you don't need to take a picture. You can just find this information from there. Any question about the project 5, space walk? Okay, so if you need to know more about the component graph, I think at least some basic what kind of plot it is. It's like a scatter plot. There are some other plots like a bar chart and some other ways. But for our case, we need to only work. Yes.
I was wondering, when it comes to Lance, the movements that he has, it's all randomized, which is how it's supposed to work. Is it supposed to have all the duplicate movements? Because it oftentimes goes so often.
Could be. Could be. It's a random thing.
So
like if you're like if you have like 4 dices, so it could be like 1 twice or 1 thrice.
So you don't want us to sort any of that out?
No.
Okay.
Whatever it is, it is. Or it could be like zigzag. 1 plus 1 minus, 1 plus 1 minus. So after 50 movements, maybe it's in the same location. Just go back and forth, doing nothing. It could be. If it is like totally random, you can put the like responsibility to randomization things. Okay, so there are a lot of plots, but in that particular case, we need to draw the scatter plot. For that scatter plot, you can see here there's a grid, there's a title, and there's some labels for x-axis labels and y-axis labels, and there are some pointers here. Title is this one, path of random walk for chart. This is for a different one. Grid is like this grid point. I already have added those information in that function, but if you need to know more, you can just investigate that function first inside that function. But at least you need to know those information. For example, you need to check this, you need to change this one, while you can change it. It's the title. You need to go to the title to change it. If you need to change the level, it's x-axis level, it's a y-axis level. Go to the x-axis level to change it. Grid is like 5 points on the y-axis level, 25, and also 5 points on the x-axis level. You can change it to 10 points, the 5 points, or 1 points. Grid can be like 1 points. So right now in one grid, you can see 5 points. I think more than 5 here. Yeah, it should be the same from this one. So matplotlib for scatter plotting, dot scatter for the grid, dot grid for the title, dot title for the label, x label, and y label. Those functions I already have written inside the plot function. If you need to modify it, you need to modify those things there. So at least if you'd like to modify it, I can help you here. These are the function to change it. Otherwise, you can keep as it is and just call that function as a library function. I haven't saved it yet, so for the save, it's like save figure, and make sure whenever you're using a file, close it. It's the file, you're using the file. After saving the file, close that file. Any question about the project? No? Okay. Almost done. What is there? Recursion. What is a recursion? Yes.
It's going through something over.
Yes. Over and over and over and over, but I can give you one chocolate. Or you can throw it to me, I can give it to you. It's an over and over and over and over. It can be. Okay, yeah. The recursion is a function calling, but
So,
what?
I was about to say itself.
Yeah. Recursion is a function calling, but the difference is the self calling. We're calling a self function again and again and again. And what happened? If I'm calling a function again and again, it calls the same function. So we have to have some condition stop it. Otherwise, it could be infinite loop, right? It could be infinite recursive function. So function. So what is a function? Basically solving a coding problem with function involving breaking down the problem into smaller problem. What we have done before, right? For our very first project, or our what's the first one? Mira and Tov. We have written those things from the scratch. Then we broke down those things in small things, like this is for the Mira share calculation. This is for the Tov's share calculation. This is for all crew calculation. Then we can create 3 different functions, right? That's what we have done. Smaller task in smaller things. But the recursion doing the same thing again and again, typically calling itself again and again. So smaller problems are variation of a large problem. This is called like a self-similar. Whenever you can find a self-similar thing, then probably you can solve this problem as a recursive way. Can you think of any self-similar type of problem? Well, you are coming every Tuesday and Thursday in this class, right? Every week until 21st, right? This is the base condition. You are calling yourself again like self-similar. That means you're coming every day. You're taking the same route, same thing, everything, but changing the date, right? Today is like till the March, right? People are saying it's a long month. So still March. Then in the next week, you're following to the April, then mid of April, end of April. This is how you can proceed. But you're calling the same function again and again. Any question? Real world scenario, summing items from a list. If you're given a list and summing those items, what can you use? A sum function, right? Or you can use a loop to iterate that list and add those items. And then if someone asks you, do not use any for loop, what can I do? Recursion is the last thing.
The last thing.
I just have mentioned. No one?
They reduce.
Reduce, yes. We can use the reduce function. With that reduce function, without using the loop, we can find the sum of the number. Now, It asks, no, you can't use a reduce function. As because reduce is taking library, like function tool. From there, you're getting this one. You cannot use it. Then what can I do? Probably recursion. But for the recursion, I need to know self-similar thing. What is a self-similar thing? Maybe I have a list of 6 items. What is a self-similar thing? I'm starting from 2 numbers, add those numbers, then go to the third. Whatever the value, adding with this third, whatever the result, adding with fourth, like 2 numbers at a time. This is like a self-similar, right? We're adding 2 numbers, but the values are different. We're proceeding to the end of the list, but at the same time, the first item is changing, is like an accumulator. In that particular way, we can use a recursive solution, but how we can solve it in a recursive way? So I think there is an example here, some illustration. Well, the very first thing is like a countdown. Well, we all have seen some countdown like during the new year, right? 10, 9, blah, blah, blah to 0. So we can draw a countdown. So what it does, start from some number, maybe 30 seconds or maybe 1 minute, maybe 59, 58. If it is going like after 0 is like -1, -2, what the heck is going on here? It's a happy new year, but it's still -1, -2. What does that mean? Well, there should be some ending situation, right? The countdown should be counting to some point down. We're counting down to 0. That was our main goal, right? That is our main goal. So here's a very naive example of countdown. I have just created a countdown and I'm putting like any value, like for example, 10. It goes here until it is less than 0. It cleared the screen. No, until it is not 0, it cleared the screen, print that n, take 1 second nap, and then call that function again with 1 second, like 1 value less. So we're calling the countdown again from the countdown, but the value is like n-1. Initially it was 10, now it was 9. Then with 9, it called 8. With 8, it called 7, so on and so forth. When it is 10 or is less than 10, so I think no, it's not 10, 0. When it's 0 or is less than 0, we just print blast off and return from that function. Okay. And this function is basically for clearing the screen. So it's Windows. Let's see for the Windows front. We already have passed 10 seconds, right? Well, it's 10, 9, 8, 7, 6, 5, 4, 3. Yeah. So this is a very basic or sample example of a recursion. We're doing the same thing again and again, but going downward. If it is showing you -1, then it never stops, right? So for the recursion of the sum of a number, for example, I'd like to sum those numbers. What I can do, this is the naive way. I have a for loop. I can add those numbers and print the sum, right? This is the very first thing that comes to your mind. Now, if they add some constraint, do not use loop. Well, I can use a sum function. It's easier. Do not use built-in function. Okay. Basically, they're looking for that particular thing, but you're not going that way. Well, then I can use a reduce function. Well, reduce is getting that function from a library function tools. We're not allowed to use any global code here. What else we have? Maybe recursion. What is the recursive way? So if we can just write those things in a parenthesis, so 1 at a time, 1 plus 3, whatever the value, plus 5, whatever the value, plus 7, whatever the value, plus 9, right? This is what we can do in our the pen and pencil thing, right? The pen and paper thing. So if we can change the parentheses, like, well, starting from the back, not from the front. So here's my list, 1, 3, 5, 7, 9. I'm starting from here, 9. Then 9 plus 7, 7 plus 5. Whatever the value plus 3, whatever the value for 1. Why we're working this way? Well, I have the list. I can access the list from the back easily, right? I can pop it up very easily. So there are two ways. Either I can slice the list or pop the last item. So slice. So pop is very easy. Like I am adding 9 first, then pop it up. I have a list of 1, 3, 5, 7. Then pop the next one, 7, 7 plus 9, whatever the value, 16. Then pop the last one, 5, 16 plus 5, 21. Pop the last one, 3. What is the value? 21. 16, 21, 24. Then whatever the value, pop it. We're done. We have nothing here. This is the one way. Other way is like, well, I can use slicing, list slicing. So what I can do, I can slice from here to here or here to here. Either way, I can slice from here to here. First, I'm taking 1, then from 1 to whatever the value. Then this is my list, new list. I'm taking this one, then slice from here. Okay, so let me write those things here. This is my list, 1, 3, 5, 7, 9. Okay, I'm taking the first item. This is our function, for example, first. This function will give me the first one. Okay, and what is the rest? Rest is another function. It will give you the rest of the list, right? I can add first plus rest. How I can find the rest? If I write L1, 1 colon end, this will give you the rest of the list. And how I can get the first one? L1, 0, right? So I have this one. I have to have an accumulator, which will definitely add this number. Accumulator is plus equal the first one, the 1. Accumulator start with 0, for example. 0 plus 1 is 1. What next? L1, right? L1, 1 through all the way. Now I will use the same thing to here. What is the first now? L1, 0. Now my L1 is changed, right? L1, 0 is now 3. And L1, 1 to all the way is 5, 7, 9. Then what is my L1? 3. So I can add it here, 1 plus 3, 4. Then again, I'm calling this one to the function again. That's what I have written here. Here's my function list sum. This is my num list. I'm looking for the first item and calling the same function with the rest. Whenever I'm calling the same function with the rest, on the next run, it has the num list with the rest of the num list, not the exact num list. If I write the code here, it could be like this way. This is my list sum. I'm calling the list sum from here, 1, 3, 5, 7, 9. It goes here. Don't worry about this one. What about the first number? 1. What is the rest? 1 through all the way, like 3 to 5, 3 to 9. I'm calling the list sum. So it is not still adding those numbers. It is waiting. What is the value of the next one? I have the first number 1 and then waiting for the other number. It goes to here, list num. Now it is 3, 5, 7, 9. What is the 3, 5, 7, 9? It goes here. Num 0 is 3. What is the num 1? 5 through 9. Calling the function again. That means We're not solving the solution on the first run. What we're doing, we're adding 1 plus calling the list sum with 3, 5, 7, 9. In that function, what is the first number? 3 plus again calling the list sum of 5, 7, 9. And again calling this one 5 plus list sum of 7, 9. Then again calling this one. First number is 7, calling the list of 9. At the very end, I have list of only one item, 9. That's what I'm checking here. Whenever the length of the list is 1, just return the first item. Now we are returning here like, well, in this particular case, he just returned the 9. I have the value 9, so I can replace it here. I'm not sure if you can see from the back. I can replace this 9 with the 9 value. What is the result now? Now I can add the add those two numbers. 9 plus 7 is 16. From where? Whenever calling this one, we need to replace this value with 16. 16 plus 5, 21. Now we're replacing with this one to 21. 21 plus 3, 24. We're replacing this 24 with this one. 24 plus 1. We're done. This is how it works. Though we have written very short lines of code, but it is doing this way. It's going all the way down. Whenever it is done, it reaches the base case and start working from there. Okay. So one good example of recursion can be a factorial. Are you familiar with the factorial? Again, it's not a math class. A factorial is like whatever the value. So if it is like a 5 factorial, it is like 5 multiplied 4 all the way to 1. When it is 20 factorial, then it is 20 multiplied 19 all the way to 1. Okay. So typically we can rewrite this factorial in a good way, a better way actually, which is like this. 5 factorial is what? 5 multiply 4 multiply 3 multiply 2 multiply 1, right? And what is 4 factorial? 4 factorial is 4 multiply 3 multiply 2 multiply 1, right? Now we can just change this 1 to 4 factorial. This is the same, right? So the equation of finding a factorial n is n multiply n minus 1 factorial. If you know n minus 1 factorial, then you can multiply with n to find the n factorial. Now, what is the n minus 1 now? Depending on the scenario, if it is like a 2 factorial is 2 multiply 1 factorial. 1 factorial is 1, but the 0 factorial is 1. So 1 factorial is like n minus 1 is like 1, right? 1 minus 1 is 0, 0 factorial. So this is our base case. Whenever we have a 0 factorial, it is a 1. Then we're returning from there. Just like our 5 factorial, if I draw this one here, so here is our 5 factorial. 5 factorial is 5 multiplied 4. Instead 5 factorial, I can write here like n factorial. N is 5. N factorial is like n multiply n minus 1, right? Now it is 4 factorial, right? On the next run, so from the first run, 5 multiply 4 factorial. I don't know what is the 4 factorial. So I'm calling this function again factorial function. What is the 4 factorial? I don't know the 4 factorial. I need to find out the 4 factorial value. 4 factorial is 4 multiplied 3 factorial. I don't know the 3 factorial. 3 factorial is 3 multiplied 2 factorial. I don't know the 2 factorial. 2 2 multiply 1 factorial. What is the 1 factorial? I don't know. I need to find out 1 multiplies 0 factorial. Well, now I know 0 factorial. So 0 factorial is 1. So I'm going from top to the bottom and then starting from the bottom. So it is the calling trace, stack. So whenever someone asks you what is the stack of your recursion, it should be like that. We're calling from here 4 factorial, like 5 factorial. This is the main function, 5 factorial. Then 4 factorial, 3 factorial, 2 factorial, 1 factorial, and 0 factorial. This is the calling stack. We're not solving 4 factorial yet. So first we're calling 5 factorial. We cannot solve it until we cannot solve 4 factorial. I don't know 4 factorial. We need to find out 3 factorial, then 2 factorial, 1 factorial, 0 factorial. At any point when you know the function value or the base case, then we start returning from here. Well, 0 factorial is 1. So 1 multiply is 1. Now the 1 factorial can be replaced with 1. 2 multiply 1 is 1. Now we can replace 2 factorial with 2. 2 multiply 3 is 6. We can replace this 3 factorial with 6. 6 multiply 4 is 24. We can replace this 4 factorial by 24. So 24 by 5 is 120. Now we can replace this 5 factorial. So this is how it works. We will be discussing those things in the next class in detail for the recursion. Okay.